Hello, good morning students. In previous class, we have studied the physical properties of metals and non-metals. Now today, we are going to study the chemical properties of metals. Electronic configuration. Electronic configuration is the basis of chemical behavior of elements. Majority of metals have up to 3 electrons in their outermost shell. Now we'll see the table. Sodium metal, which is having atomic number 11, and the electronic configuration is 2, 8, 1. Next element, magnesium, atomic number 12, electronic configuration is 2, 8, 2. Aluminium, atomic number 13, electronic configuration is 2, 8, 3. So, the formation of ions. Metals have a tendency to lose their valence electrons to form positively charged ions, that is cation ions. See here, metals, to complete in the table you can see, to complete their octet they have to lose the electrons. So, we will see one by one example. Sodium, the configuration is 2, 8, 1. To complete the octet, sodium loses 1 electron from outermost orbit and it forms sodium ion with Na plus 1E minus. Next element, that is magnesium. Configuration is 2, 8, 2. Then magnesium, to complete the octet, loses 2 electrons. Then it forms magnesium cation, that is Mg plus 2E minus. Next, aluminium. This metal, it has configuration 2, 8, 3. Means to complete the octet, aluminium loses how many electrons? 3 electrons. And then it becomes aluminium cation, that is aluminium ion. Configuration is 2, 8 plus it loses how many electrons? 3 electrons. Reaction with oxygen. Metals combine with oxygen to form their oxides. Metal plus oxygen forms metal oxide. See, if we take red litmus paper and if we dip in the metal oxide solution, then it turns into blue color, means the metal oxides are basic in nature. So, metal oxides react with an acid to form salt and water. That equation is metal oxide plus acid forms salt plus water. Example, aluminium oxide Al2O3 plus 6HCl. HCl is acid. Oxide react with acid and forms AlCl3, that is aluminium chloride and water. Next, reaction with acid. Take dilute hydrochloric acid in a test tube, then add zinc dust to it, and then take a glowing splinter near the mouth of the tube. Then what we will notice? We can hear the pop sound coming out from the test tube. It means that hydrogen gas is formed. Most of the metals react with dilute acids to form metal salts while hydrogen gas is released. Metal plus dilute acid forms salt plus hydrogen gas. Next, reaction with water. Most metals do not show any observable and fast reaction with cold water, but some metals like sodium and potassium react with cold water to produce their hydroxides and hydrogen gas. Now we'll study the chemical properties of nonmetals. Electronic configuration. Most of the nonmetals have 4 to 7 electrons in their valence shells. Now we'll see the table. So, non-metal atomic number 7 and the electronic configuration is 2, 5. Next element oxygen, atomic number 8 and the electronic configuration is 2, 6. And chlorine, atomic number 17 and the electronic configuration is 2, 8, 7. Now we will see the formation of ions. Non-metals have a tendency to accept electrons in their valence shell to form negatively charged ions called anions. So here non-metals, to complete their octet in the outermost orbit, they are going to receive or accept electrons. We will see the examples. Chlorine, its electronic configuration is 2, 8, 7. Then how many electrons are required for chlorine to complete the octet? 1 electron. So it receives 1 electron and it forms chlorine anion Cl minus and the configuration becomes 2, 8, 8. Next oxygen. Oxygen configuration is 2, 6. Means oxygen requires again 2 electrons to complete the octet. So it receives 2 electrons and it forms oxygen anion, that is O minus minus. The configuration is 2, 8. Next nitrogen configuration is 2, 5. Means how many electrons are required for nitrogen? 3 electrons to complete the octet. So it receives 3 electrons and forms nitride ion N minus 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 and the configuration is 2, 8. Reaction with oxygen. Non-metals combine with oxygen to form their oxides. Non-metal plus oxygen, non-metal oxide. For example, C plus O2 forms CO2, carbon dioxide. And if you take a blue litmus paper and dip in the solution of non-metal oxide, then it turns to red. It means that the oxides of non-metals are acidic in nature. And see, these non-metal oxides, they react with the base and form salt and water. For example, carbon dioxide react with the base sodium hydroxide, that is NaOH, and forms salt Na2CO3, sodium carbonate and water. The oxides of non-metals react with water to form an acid. CO2 plus H2O forms H2CO3, that is carbonic acid. SO2 sulfur dioxide plus water forms H2SO3, that is sulfurous acid. And SO3 sulfur trioxide plus water forms H2SO4, that is sulfuric acid. And non-metals do not react with dilute acids. Students, the next part of the lesson we'll see in the next video.